Okay, guys, this is motion vocabulary part 2. I'm going to go ahead and go over the second half of the terms here. And make sure to pause as you need so you get the definition and the pictures. And make sure to listen to the explanations. If you don't understand something, please ask. We will be using these. Okay, so speed is the rate at which an object moves. You're very familiar with the term speed. Usually in our everyday lives, speed is for cars, right? And that's going to be like miles per hour, right? Per is this little division sign here, so don't be freaked out by that. But usually we are going to use meters per second. Okay, that's a much more common use in meters per second. M for meter, S for second. The divide sign is per. Okay, so that's speed. It's worth noting that speed is a scalar quantity, so make sure you write that out here. It's scalar. That means no direction. And we don't care about the direction. This is meters per second, not meters per second south, west, north, east, northwest, etc. The average speed, this is the total distance divided by the total time. So speed is just kind of like a general, something is moving, the rate at which something is moving. But average speed is an equation. Okay, so this is average speed is your distance divided by time. Okay. All right. A constant speed is a constant rate of change in position going the same speed for an extended period of time. Okay, so constant speed, that would be like in your car hitting the cruise control, right? So the cruise control means that you can set whatever speed you want. You're going to keep going that way for a long time. On a distance time graph, right, or a displacement time graph, where distance is the dependent variable, time is the independent variable. A constant speed would look like this, right? Just like a straight line. Right? That's one way to do it. Another way to do it would have a constant speed of 0, right? Or even like a negative speed here, so you can have a speed that's going downhill, right? Okay, so all of these, as long as the lines are straight, these are constant speeds. Okay, keep this in mind, we're going to be doing this in a couple days here. Okay, instantaneous speed, the speed given at a snapshot, right? A certain point in time. So let's say this is your speedometer in your car. Bam! Take a snapshot right here. This would be your instantaneous speed at that instant. Okay, this is an equation for speed. Speed is distance over time. Notice that it's distance, which again is scalar or vector. It's scalar, which means we don't care about the direction. It's a formula for how fast an object is moving. Okay. Velocity is a special type of speed. Okay, so it's kind of look at these real quick. They're similar. They're a little bit different. Okay, velocity is speed, but in a given direction. So if you care about the direction, is this vector or scalar? It's got to be vector. Just think of the word vector. It means arrow. Okay, vector means arrow, and you're going to see that in a minute. All right. Okay, so how is speed different from velocity? Well, let's look. Speed is distance over time, but velocity is displacement. And if you remember what displacement was, that was the distance it moved from the starting point. So let's look here. Remember, distance would have been 7 if we added these up, but displacement would be just the hypotenuse of this triangle. So 3, 4, 5, right? All right. So which number would you plug in for distance? Let's say this happened over a period of 10 seconds. If you were doing speed, you'd plug in the distance, so 7 over 10, right? But if you're doing displacement, you would put in 5 over 10, right? See, 7 divided by 10 versus 5 over 10. All right, acceleration. You've heard this word before. Basically, it just means speeding up, right? It's the rate of change of velocity, not the rate of change of speed, but the rate of change of velocity. And it's important because in our everyday lives, we know we can accelerate, we can get faster, even if we're talking about speed in our car. But the reason it applies to velocity even more is because, look, there are 3 ways to speed up. Three. You can either speed up, you can slow down, or you can change direction, which is a fancy way of saying this. Turn. Okay, turn. Okay, and go ahead and draw something like this, like a little flickery speedometer. You don't have to draw this exactly, but just show kind of like a needle moving. Or you can show a car with just like 1 or 2 lines versus a lot of lines, right? It's like speeding up. Okay. Inertia. Now we're getting into force here. It's a property of matter to resist change in motion. So what you need to write here is that this basically means the word mass. If you have mass, you're going to have inertia. And guess what? The more mass you have, the more inertia you have. Okay, and look at this. Here's a perfect example. Here's a perfect example of that. We have an elephant versus a mouse. Which one's easier to move? Well, this one has a really high mass. This one has a really low mass. So the elephant is harder to move than the mouse, right? Okay, weight. This is just a fancy way of saying force gravitational, because it is the gravitational force exerted on an object, and specifically its mass. Okay, the gravitational force exerted on mass. That's how mass and weight are different. Okay, because look here, the equation for weight is mass times gravity, which we use as 9.8. Okay, 9.8 meters per second squared. So it's a kind of like an acceleration. And speaking of which, acceleration is symbol A, measured in meters per second squared. Velocity, V is the symbol. So if you see a V in an equation, you know that it's velocity. And this is measured in meters per second. Okay? Speed also measured in meters per second. So these are the units you have to put at the end, right? So it's like saying, what is your mass? 64 what? 64 kilograms, right? Well, speed would be, how fast were you going? You could say 10 meters per second. Velocity, you could say 10 meters per second. Acceleration, what was the rate that velocity changed? Well, you could say 2 meters per second squared or 10 meters per second squared. That's how you would say that. Okay, weight is measured in N, which is newtons. So if I have a mass of 64 kilograms, and I want to, multiply it by gravity. All right, so gravity is going to be about 9.8 meters per second squared. So you end up with a little under 640, okay, a little under 640 newtons. So about 640 newtons. That would be my weight, okay? All right, draw a little scale for that. All right.